and welcome to the Atmel booth. My name is Neil Rice. I work for the Atmel Corporation's Microcontroller Group. What I'm going to be talking about today is our AVR products, our product line, our development tools. Just a very quick introduction to you, and then we're going to show you a very quick video which hopefully convinces you that it's quick and easy to use our development tools. So please feel free to stop me and ask any questions at any time. Okay, so what is the AVR architecture? The AVR architecture is a flash-based microcontroller system that spans 8 bits up to 32 bits, everywhere from simple 6-pin 1K AVRs all the way up to 100 MIPS plus embedded 32-bit processors, all running from flash, all designed to be one architecture, one family, one set of development and design tools. We've designed a lot around low power, what we call our Pico Power family. This is both low active power consumption and also low static or standby power consumption as well. The parts are designed to be traditional microcontrollers. That means they don't have or require an awful lot of external components to get running. They have onboard flash, onboard SRAM, onboard watchdog timers, onboard brownout detect, onboard oscillators, onboard JTAG, development systems, everything kind of built into a single part. The idea here is you put down a couple of external passive components and you're ready to go. We design parts that support 5 volt, we design parts that are designed for noisy environments with ESD, EMI, all kinds of issues like that. These are parts that are designed to be able to work through that environment, all again using the same design tools, the same design flow, and quickly and easily moving from one part to another. Part of ease of design is being able to quickly and easily get up and running with development tools and with software, not having to reinvent the wheel every time. What we try and take and do across all our families is reuse the same peripheral blocks, reuse design tools and application notes to be able to allow customers to get moving quickly. So we build in a software framework. What this allows you to do is select certain functions you'd like to implement. Maybe it's a SPI driver or an I2C driver. Maybe it's a USB host controller for mass storage. Maybe it's an external LCD controller you want to drive. You pick the requirements that you want, drag that into our software framework tool, build it, and you already have a quick head start in your application. That will run on our development boards and allow you to get moving quickly. On top of that, we have a bunch of different application notes that are there to allow you to get started on a particular peripheral. Say it's a USB device, you don't want to have to write the mass storage class device driver yourself. We have an application note that has that in there that's targeted at all our different compilers and development tools and development boards. You can quickly take and use that within your project and migrate that around your designs as they change. White papers, we have some overview papers that kind of describe why our architectures fit well for particular applications, whether it's things like smart metering, whether it's things like consumer devices, maybe it's things like user interface or capacitive touch. Our white papers give you an overview of that. And finally, we have a lot of applications experts, not just here in this booth where we have a number of different people, but in our local areas through our field applications engineers and through our channel partners, distributors, applications engineers as well. Plus our support teams gathered globally are in a position to be able to advise you on aspects of your design. Just let us know, and if you have any questions on that, grab one of us here at this booth and we'll be happy to talk to you about the specifics of your design. Okay, so what is the AVR family? It starts from our tiny AVRs. These are very low footprint, intended to be low power, low-cost microcontrollers all the way down to 6 pins or a little SOT23 package. They start at even half a K and are there to embed very simple control, but they use the same architecture as our mega families, which go up to 100 pins, give you up to 256K of performance. They're there for 8-bit applications, for metering, for consumer products, for industrial, for HVAC, for all these different areas. A huge different variety of packages and peripherals spanning from 8 pins all the way up to 100 pins, 144 pins. Within these devices, we do a lot of parts that are pin and code compatible. What that means is you can take one design and as you add features, you don't have to relay out your board or even necessarily recompile your code. So you can just build and develop in terms of the project you've already worked on. We've just introduced a new family of X-Mega microcontrollers. They use the same core as the Mega AVR, but add in some features that are there for low power and high performance in embedded microcontrollers. This is our DMA system. You can automatically transfer information backwards and forwards from our serial peripherals in and out of memory without the processor being awake or being interrupted in terms of what it's doing. And an event system where we replace interrupt service routines with automating what the microcontroller can do in terms of transferring information backwards and forwards. A good example is automatically reading from an ADD controller based on a threshold value, taking that in and spitting out an SPI message or a PWM output based on that value. All that can be done using our event system without even waking the processor up. So it's a really quick and deterministic way of adding that capability to your microcontroller without burdening the processor with the additional load of maintaining that real-time critical task. And finally, we've introduced our UC3 AVR 32 microcontrollers. This is part of the AVR family. This is a 32-bit microcontroller core that's based around running from Flash, but also adds in DSP-like capability as well, and in some of our newer processors, even floating point units built in. So it's a very broad and capable family for high-speed USB, dual CAN, Ethernet, and a whole variety of different 32-bit-like applications. The nice thing about all this is we use the same development tool suite for all those different things, all the way from the 1K part up to the 100 MIPS 32-bit processor. We have our own debuggers. We have a common software platform called Atmel AVR Studio. It's free. It's available to download from our website. We have our own GCC compilers for both the 8 and 32-bit variants that are free, fully supported, and are followed up with our Atmel application notes and also with our software framework. Plus, we partner with some of the best-in-class compiler vendors for 8 and 32-bit, IAR, Kyle Arm, a number of different people. So we also make and develop our own starter kits that are in here to allow you to put boards down, use the application note of the software framework, use the debuggers to quickly and easily get an application prototype up and running, or to use this as a development environment while you wait for your PCBs to come back from your manufacturer. It's quick and easy and fully supported. All these tools are available from Atmel or from our registered distributors or from our catalog distributors like Mouser or DigiKey. So this simple setup, an AVR debugger, which also has some trace capability, and this SDK 600 board will cover all of those different parts. So everything from 1K, 6-pin, all the way up to 100 MIPS plus 32-bit microcontroller. So to show you how easy it is, we have a very quick video that shows you getting up and running on one of our eval boards in 1 minute exactly. This is taking one of our AVR 32 boards, using the Studio framework that we have, and using our debugger. Very quickly, we plug the debugger in, the board powers up, we load in AVR 32 Studio. This is our free development environment available from our website. Go in here, select the board we're targeting. This happens to be one of our UC3A3 or A0 boards. Open the project from the framework, pick an example. In this case, we're having an example which uses the display on the board. Pick it, it loads. Build the project using the GCC compiler that's available for free with the development environment. Project builds. We're at 40 seconds now. I have a feeling we're going to make it. Debug, using our JTAG debugger. Download the application through. Switch to the debug environment and window. Start debugging, and the board comes up and runs in 1 minute. It's a very simple tool, very powerful, very flexible. And what we did there again is take a full application, debug it, and run it in 1 minute. Thank you very much for stopping by to listen. We have a number of different demos set up here that show off our different technologies, our 8-bit, our 32-bit platforms, our touch technology, and also some of our MCU wireless technologies as well. Please feel free to stop by, and thank you for coming.